Here are the solutions for some of the problems on the Chapter 3 review, Day 2. I haven't done every question because you can find the fill-in-the-blank answers on the answer key paper. So starting with number 3, we're asked to find 3 roots to this equation, and we must find those roots from the domain of the integers. So we can't have any fractions or decimals when we do this. Let's solve this equation for y because that'll help us find answers. First, subtract 3x. We get 4y equals 5 minus 3x. Then divide by 4. We get y equals 5 divided by 4 minus 3 divided by 4x. Let's organize our 3 solutions in an xy table. We want to choose integers for x. So one integer is 0. Let's substitute that into our expression that will find us the answer for y. 3/4 times 0 is 0, so this turns out to be 5/4. This first root is 0, 5/4. Let's choose another integer to substitute for x, maybe 1. Y equals 5/4 minus 3/4 times 1. 3/4 times 1 is 3/4. 5/4 subtract 3/4 is 2/4, and this reduces to a half. So this root is 1, 1/2. Let's choose another integer for x, maybe the number 2. Y equals 5/4 minus 3/4 times 2. 3 times 2 is 6/4. 5/4 minus 6/4 is negative 1/4. So our root is 2, negative 1/4. For number 4, similar idea, we want to find 3 solutions to the equation using positive integers as our domain. Let's solve this equation for y by subtracting 3x. We get negative 2y equals 1 minus 3x. Then divide by negative 2. Y equals 1 divided by negative 2 minus 3x divided by negative 2. Let's simplify this. This is y equals negative 1/2 plus 3/2x. Let's put our answers in an xy table. Now we're looking for positive integers, so this time we don't want to use 0. That's not a positive integer. But 1 is. So y equals negative 1/2 plus 3/2 times 1. 3/2 times 1 is 3/2. And negative 1/2 plus 3/2 is 2/2, which reduces to 1. So this is the root 1, 1. Let's try 2. Y equals negative 1/2 plus 3/2 times 2. 3/2 times 2 is 6/2, which is really just a 3, and negative 1/2 plus 3 is 2.5. So this root is 2, 2.5. Let's use another positive integer for x. How about 3? Y equals negative 1/2 plus 3/2 times 3. 3 times 3 is 9/2. Negative 1/2 plus 9/2 is 8/2. And that reduces to a 4. So this root is 3, 4. Here are 3 roots or solutions to the equation. Number 5 is one of those word problems that say, find the 2-digit number. And then it gives us clues about the digits. So there's a tens digit in a 2-digit number, and there is a units digit in a 2-digit number. We don't know what these digits are. Let's represent them using an x and a y. Now let's read the sentence and create expressions using x and y. We're told that the tens digit is, so x equals 1 more than twice the unit digit. So that would be plus 1, and then we're adding that 1 to twice the units digit, 2y. There are no more clues, so we can't make any more equations. When you have only one equation but two variables, you will get multiple solutions. Let's pick a digit to put in for y so that we can solve for x. Maybe y is the number 0. Then x turns out to be 1. This would mean that our two-digit number is a 1 followed by a 0. It's the number 10. But that's not the only possibility. We could have tried another number for y, such as the number 1. And if we work this out, we get 3. That would mean that our two-digit number is a 3 followed by a 1, or the number 31. There are more two-digit numbers that we could find. Number 9, we are told that -3, -4 solves this equation. That means if you substitute this for x and this for y, you get a true equation. Let's substitute and then solve for k. So for the letter x, substitute -3. For the letter y, substitute -4. Now let's simplify. 5 times -3 is -15k. 2 times -4 is a -8, and that's equal to 7. Now add 8 to both sides. We get -15k equals 15. Therefore, k is -1. For number 10, we're given a system of two equations, and we're asked to graph them on the grid. Then find the solution to the system by looking at our graph. This equation is almost in slope-intercept form. It has the letter y alone. We just need to switch where the -2x and the +1 are located. Now we can see our slope and we can see our y-intercept, and we can graph that line. So the y-intercept is at +1 and the slope is -2. Down 2, right 1. Down 2, right 1. Let's draw a nice straight line through those dots. Now the next equation. It is already in slope-intercept form. We can see that the slope is 1 and that the y-intercept is 7. So the first dot's at 7 on the y-axis and the slope is 1. You go up 1, over 1. I could continue upwards, but that's not really taking me towards my other line. So let's actually go down 1, left 1, down 1, left 1, and draw a line through those dots. Now we can find the solution to the system. It is this point here where the lines intersect. This seems to be on -2 on the x-axis and at +5 on the y-axis. It is the point -2, 5. We can confirm that that's the solution by substituting -2 for x and 5 for y to make sure that that is really a solution to the first equation. We would also want to substitute -2 for x and 5 for y in the second equation to confirm that it really solves that equation. Next, number 11. Same idea. Let's graph both lines to see where they intersect. This first equation is in standard form, so finding the intercepts would be a good way to graph it. When r is 0, s is 2. And when s is 0, r is 6. These are the intercepts. 0, 2 is a dot, and 6, 0 is a dot. Then carefully draw a straight line through those dots. The second one is also in standard form, so using intercepts would be a good way to graph it. When r is 0, s is -3. When the s is 0, the r is +3. 0, -3 is here, and 3, 0 is here. And draw a nice straight line through those dots. The solution to the system is this point where they intersect each other. That seems to be at 4 on the x-axis and 1 on the y-axis. 4, 1. We can confirm that that works by substituting 4 for r and 1 for s and making sure that this really works out to equal 6. We would also want to put in 4 for r and 1 for s in the other equation to check that that really works out to equal 3. Number 15, we are given two ordered pairs, and we're asked to find the slope of a line that would go through those ordered pairs. We don't have to graph to do this because we have the slope formula. M equals y2 minus y1 divided by x2 minus x1. In the first ordered pair, you have your x1 and y1. In the second ordered pair, the x2 and the y2. So y2 is -3. y1 is 3. x2 is 6. x1 is -8. Now let's simplify. We get -6 on top and 14 on the bottom. This reduces to -3/7. That's our answer for M. Number 16, we want to find the value of M. We want to find the slope. This equation only has the letter y, so it's a special case. It is a horizontal line, so the slope is 0. Number 17, we want to find the slope of this line. We don't have to graph it first. We can find the slope from the equation. Let's put this in slope-intercept form. Subtract 3x. We get -5y equals -3x plus 6. Now divide by -5. We get y equals -3x over -5 plus 6 over -5. Let's simplify. This is +3/5 x and then minus 6/5. The slope is the 3/5. So changing the equation from the ax plus by equals c form into slope-intercept form gives us a way to find the slope. Number 18, graph a line through this dot that has this slope. Start with the dot. 4, -1 is located here. Now use the slope. This is the same as -2 over 1. This is our rise, and this is our run. But because the rise is a negative number, we're really going to go downward. So from our dot, count down 2, and then run 1 to the right. Draw a line through those dots. Number 19, same thing. Graph the dot, then use the slope to get another dot. -3, 0 is here, and if the slope is 2/3, you rise 2, and then run 3 to the right. Draw a line through those two dots. Number 20, we are given 4 ordered pairs in a chart, and we're asked if these line up in a straight line. We can find this out without graphing them. We need to see if the rate of change from point to point is constant. So let's find the changes in each variable. Start with the letter S. From -3 to -1, that has increased 2 units. Now the letter T. From -4 to -1, that has increased 3 units. Let's make a rate out of that. And when we make the rate, let's put the change in the T on the top and the change in the S on the bottom. So the rate is 3/2. Now let's see what the rate is between the other dots. From -1 to +1, it increases 2. And from -1 to 2, it increases 3. So making a rate out of that, it's also 3/2. Now over here, from 1 to 5 is an increase of 4. From 2 to 8 is an increase of 6. Let's make a rate, 6/4, which reduces to 3/2. Notice we have the same rate of change from one dot to the next. So our answer is yes, these do line up in a straight line, and the slope of that line is 3/2. Number 21, same instructions. Let's see if these line up in a straight line. From 0 to -1, is a decrease of 1 unit. From -1 to 0 is an increase of 1 unit. Let's now look at the rate. And when we do this, we want to put the change in the y on the top and the change in the x on the bottom. So we have 1 over -1, which equals -1. Let's look at this one to this one. This is a decrease of 1 and an increase of 3. So when we make the rate, we have 3 over -1, which equals -3. These are not the same rate of change. So our answer is no. These dots will not line up in a straight line. Number 22 is really the same question. It's just we're given our ordered pairs in parentheses instead of in a chart. But if we want to know if they're collinear, which means that they line up in a straight line, we want to find the slopes or the rate of changes. We want to know, is there a constant rate of change? So let's start with these two and figure out what is the rate of change. From -3 to -2 is an increase of 1 unit. From 0 to 2 is an increase of 2. That rate of change is a half. Now let's look at this ordered pair and the third ordered pair and figure out m. From -2 to +1 is an increase of 3. From 2 to 8 is an increase of 6, and this reduces to a half. This is looking good so far. We know that those line up. We have one more pair of ordered pairs that we need to check. We haven't yet checked the first ordered pair with the third ordered pair. So let's find that rate of change. From -3 to +1 is an increase of 4 units. From a 0 to a +8 is an increase of 8 units, and that reduces to a half. So notice we get the same rate of change every time from dot to dot. That means that they do line up in a straight line. The word is collinear, so we have shown that they are collinear. Number 25, find an equation for a line if we're given its slope and if we're given its x-intercept. Remember what x-intercept means. It is a point, and it's the value of x when the y is a 0. So in question 25, we're given the slope and we're given a point. Let's use point-slope form. The formula is y minus y1 equals m times x minus x1. x1 and the y1 come from our point. That's the x1, that's the y1. Let's make our substitutions. Y minus 0 equals, for m, fill in -1, and then x minus 3. This is an equation. We could leave it like this, or we could work on it a little bit. For example, y minus 0 is really just y. -1 times x is really -x, and -1 times -3 is really +3. This equation is in slope-intercept form. It's a little nicer to look at than this one here. Number 26, let's write an equation. This time we're given the x-intercept and the y-intercept. Remember what these are. These are ordered pairs. The x-intercept is the value of x when y is 0. The y-intercept is the value of y when x is 0. So in number 26, we're really given 2 ordered pairs. We're not told the slope, and if you're going to write an equation of a line, you have to know the slope. So our first thing to do is find the slope. Let's use the slope formula. That's the y2 minus y1 over x2 minus x1. From 0 to 2 is an increase of 2. From -1/2 to 0 is an increase of 1/2. And 2 divided by 1/2 is 4. We now know the slope, and we know the y-intercept. So let's use slope-intercept form. The formula for that is y equals mx plus b. Let's make our substitutions. For m, we got 4. and b is our y-intercept, we were told that that was 2. So here's our equation. Number 27 is the same thing as number 26. We have 2 ordered pairs. So let's start by finding the slope. From -1 to +6 is an increase of 7 for the y-coordinates. From -5 to +2 is an increase of 7 for the x-coordinates, and that reduces to 1. So here's our m value. Here's our x1 and our y1. We'll use the point slope formula. Y minus -1 equals, now here's the 1, which was our m, and then in parentheses, x minus, and the x sub 1. We can leave it like this. This is called point slope form, or we could simplify it and make it look nicer. This becomes y plus 1 equals x plus 5. Now subtract 1 from both sides. We get y equals x plus 4. Number 28, let's write an equation for a line. It goes through 2, -7, and it is parallel to this equation. Parallel lines have the same slope. So let's find the slope of this one. Subtract 5x from both sides. We get 2y equals -5x plus 3. Now divide by 2. We get y equals -5 over 2x plus 3 over 2. The reason that we did that was to find the slope of that equation. We want to make an equation that goes through this point and has that same slope. So we have a point and we have a slope. Let's use point slope form. Y minus, fill in the -7 equals, fill in the m, and then x minus, and fill in the 2. Again, we could leave it like this, or we could change this equation to a different form. I'm going to leave it like this. Number 29. Again, we're asked to write an equation, and we're given some information. We're told the y-intercept of our equation, and we're told it's parallel to this one. So if it's parallel, it has the same slope. Let's find the slope of this. Subtract 4x from both sides. -6y equals -4x minus 1. Then divide by -6. We get -4x over -6, and then minus 1 over -6. Let's simplify this. Negative divided by negative is positive. 4 over 6 reduces to 2/3 x. Negative divided by negative is positive, and this is 1/6. The reason that we changed the form was to find that slope right there. We have the slope and the y-intercept. Let's use slope-intercept form this time. Y equals, fill in the m, and then fill in the b. There's our equation. Number 33, we're given a system, we're asked to solve it. We can use combination or substitution. I'm going to choose combination. I want one of the variable terms to be opposites. Because the top one has a -2y, I would like the bottom one to have a +2y. I think that I can transform it into that if I times by 2. 2x times 2 is 4x. Y times 2 is +2y. And 2 times 2 is 4. Now keep the top equation the same as it was. Now let's combine them by adding the columns. This becomes 10x, the y terms cancel, and over here we get 15. Divide both sides by 10, and we get x equals 15 over 10, which is 1.5. We're halfway done. We have the answer for x. Take that value and substitute it for x in either the first equation or the second one, whichever one looks easier. I think that second equation looks easier. It's got smaller numbers. So 2 times, fill in 1.5, and then plus y is equal to 2. 2 times 1.5 is 3. And now subtract 3 from both sides, and we get y equals negative 1. As an ordered pair, we have 1.5 comma negative 1. Number 34, let's solve this equation. And this time, I'm going to use substitution method. Do you see why? It's because the second equation has already been solved for one of the variables. We can take this binomial and substitute it for the letter s in the first equation. So the first equation will transform into 4r minus 2. And then in parentheses, fill in the 2r minus 1.5. And that's equal to 3. Now solve this. First, the distributive property. Negative 2 times 2r is negative 4r. Negative 2 times negative 1.5 is positive 3. Now combine like terms. 4r take away 4r is nothing. So there are no r's left over. We have 3 equals 3. We got a true statement with no variables in it. This means our system is a special case. Every solution that works for r and s in the first equation will also work for r and s in the second equation. There's a vocab word that you use for this kind of system. The equations are dependent. Number 33 was different. In number 33, we didn't get multiple solutions, we got only one solution. That system was called consistent. Next, number 41, we're asked to graph this inequality on the grid. Let's put it in slope-intercept form by subtracting 3x from both sides. Negative y is greater than or equal to negative 3x plus 1. Now divide everything by negative 1 to remove the coefficient. Switch the arrow because we divided by a negative 1. We get positive 3x minus 1. When we graph, we're going to have a solid line because of this or equal to. And because of the less than, we're going to shade under that solid line. The y-intercept is negative 1, the slope is 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Here's our solid boundary line, and we're going to shade under the boundary. Number 42, we have a system of inequalities. Let's graph both boundary lines and then figure out where to shade them. Let's transform the first inequality to slope-intercept form by subtracting x from both sides. We get 2y is greater than or equal to negative x plus 2. Now divide by 2 on both sides. Y is greater than or equal to negative 1/2 x plus 1. Let's graph that. Y-intercept at 1 and a slope of negative 1/2. Down 1 over 2. Down 1 over 2. Because of this extra little bar, it is a solid line. We're going to shade above that line because of the greater than. Let's take the second inequality and transform it by subtracting 3x from both sides. We get negative 2y is greater than negative 3x minus 8. Then divide by negative 2. Y is less than 3 over 2x plus 4. So the y-intercept is at 4, and the slope is up 3 over 2. 1, 2, 3, and then over 2. We could also go down 3 and left 2. This one does not have the equals line, so this is a dashed boundary line. Because this is a less than arrow, we want to be under the dashed boundary. Do you remember where we wanted to shade for the solid boundary? Above. Above the solid line, but below the dashed line. Here is our shaded region.